I am Henry Trimuktiradian. I am the student of the SBM ITV. I'm going to explain the microeconomic barriers to electric vehicle adoption in Indonesia. This is a multidimensional analysis in national and global context. And this is the outline. We are going to discuss about the abstract, the introduction, theoretical framework, and for the number 4 until 7, we are going to get discussion about the microeconomic barriers. They are the financial barriers, infrastructure barriers, market and supply chain barriers, behavioral and informational barriers. Then another one, global context, synthesis and policy recommendation. And the last one, we are going to get this discussion about the conclusion. The next one is for the abstract. This is the EV adoption challenge. Indonesia's ambitious goal for getting more electric vehicles are running into a lot of problems because of the microeconomic factor. This study looked at the financial, infrastructural, market-based, behavioral, and global obstacles to widespread EV adoption in Indonesia. This study finds that the high upfront price, lack of charging infrastructure, limited models, supply chain vulnerabilities, and behavioral factors are the key obstacles. This study showed that the Indonesian nickel reliance faced vulnerability as the world moved toward lithium iron phosphate batteries, and the problems are worsened by the inconsistent policy and electrical infrastructure issue. Then the report ends with the specific policy suggestion for making the EV ecosystem more welcoming, stressing coordinated effort. Then this is the condition of the Indonesian comparison global and local adoption. And Indonesia as the critical market for the global EV adoption. We are the fourth most populous nation with the rapidly growing in the middle class, and our government put the target to have 2 million electric cars and 13 million electric motorcycles by 2030. It will be supported by 30,000 public charging stations and 67,000 battery swapping stations. It will align with Indonesia's commitment to reduce the greenhouse gas emission, and for the transportation, it will contribute 15% for the national emission. And the next one for the comparison for global and local adoption. And in globally, currently for 2023, we had 14 million new electric cars registered. In total fleet, we had 14 million in total. But for the growth itself, it was concentrated in some areas. In China, we have 60%, the Europe 25%, and United States, it will have 10% for the numbers. And for the Southeast Asia, less than 2% of the global EV market. Indonesia is the region second of the market after the Thailand. And locally for Indonesia, domestic EV penetration remains low. It's about 1.7 of total cars, and it's less than 5% by early of 2025. The next one, theoretical framework for the EV adoption. There are some different point of view related with the EV adoption. The first one, this is from the consumer point of view. For the rational consumer, evaluate EV based on the utility maximization, weighing higher upfront costs against the lower operating expenses. Then the next one, the total cost of the ownership, the TCO, is a critical metric as well. And the last part, for the consumer point of view, Indonesian consumers are sensitive to upfront pricing with high loan interest rate. The next one, from the production point of view, production theory and economic of scale. The automakers require minimum efficient scale for EV production, challenging in Indonesia small initial market. Limited domestic capacity forced reliance on import, creating high prices, and charging infrastructure providers face high fixed cost and network effect. And for the point of view of the market failure framework, there are information asymmetries, and it's more give the consumer like the awareness. Then there are still positive externalities and are not captured in private transaction and justifying the policy. And the last one, for the behavioral economics, non-rational factor like the status quo bias. Then the last one, the present bias caused by customer to overweight immediate cost against long-term saving. Let's dive into the microeconomic barriers. The first one is for the financial barriers, and there are three main reasons for the barriers from the financial point of view. The first one, the high upfront cost differential. Second one, the total cost of the ownership, the TCO paradox. And the third one, the fiscal incentive limitation. The first one, the high upfront cost differential. The electric cars in Indonesia, the price is ranging from the about 11,000 to 250,000, and it's a 40 until 60% of the premium of our equivalent gasoline vehicle in Indonesia, and primarily due to the battery costs and import duties. And entry-level EV represent 18 until 22 months of the median household income. In annually, we only had $8,000. The second one, total cost of the ownership paradox. The lower operating cost itself, energy efficiency, and reduced maintenance are diminished by the high electricity cost itself. Then for the battery replacement cost, and it can be about 5,000 until 7,000, and it can be conducted every 8 until 10 years, and it will create significant future for the financial liabilities. The last one, for the TCO paradox, the elevated consumer discount rate lead to the overweighting near-term cost over the long-term saving itself. Then the last one, for the detailed fiscal incentive limitation, and currently our GOI incentive is still reduced price by 10 until 11%, and it's still inconsistent implementation. And unlike the China, Indonesia incentives are fragmented, causing the policy uncertainty. And for the incentive itself, disproportionately focus on four-wheel vehicle despite for the motor vehicle itself. Even though the vehicle market in total we have about 120 million units. Goes to the infrastructure barriers, and let's say we can put the three main reasons: inadequate charging infrastructure, high investment cost and business model challenge, and the grid capacity and power source concern itself. Okay, let's take a look for the every single part. For the inadequate charging infrastructure, only 3,200 charging stations targeted for 2024 nationwide, compared with the 30,000 by 2030, and approximately the comparison, it can be 1 compared with the 100 charger to EV ratio in urban centers, and the optimum number is supposed to be comparison at the 1.6 until 1.10 in major markets. Then the heavy skew toward Jakarta and Bali it's only, and it can be creating the charging desert across the archipelago in general of the Indonesia. Then for the high investment cost and business model challenge, and currently public fast charging station for the capital investment, it need to be 40,000 until 100,000 for the capital investment, and for the battery swapping, and it can be even higher. And for the operators, they are facing a low utilization rate during the early adoption and resulting in extended payback period, and it can be more than 7 years. And for the PLN, time of use tariff for the commercial charging, and it's already reduced in until the thin margin. Then for the power source constraint, and currently Indonesia electricity grid limitation, especially outside Java and Bali, and electricity generation itself remains dominated by the coal, 67%, and fossil fuel, and it can be generate another problem. And despite about 3,700 gigawatt renewable energy potential, it's only 14%. It can be generated for the 14% for the renewable generation. The next barriers is market and supply chain barriers. This is basically from the production of the automaker's point of view. There are three main reasons for the barriers. The first one, the limited model availability and consumer choices, battery production complexity, and circular economic gaps. For the first one, limited model availability and consumer choice. Market suffers from the limited model diversity, especially in affordable segments. Mass market offering are scarce with the luxury brands dominating. The absence of the competitively priced segment city cars and the electric pickup, it's quite popular in Indonesia. And for the automakers, mentioned in Indonesia as the small market size, and another component for the local content requirement, the TKDN, as the barriers to introducing the diverse model. Then for the battery production complexity explanation, we have three another reason. And the first one, for the downstream processing limitation. Despite the nickel ore export ban, Indonesia remains a raw material exporter. From concern of the environmental, social, and governance, poor environmental or labor practices deter the international investor. And for the technological shift risk, rapid global transition toward the LFP battery, chemistry city, threats to devalue Indonesian nickel advantage. And the last one, for the circular economic gaps, the end of life battery management present a challenge, with the potential replacement cost exceeding 5,000, significant impacting the TCO. Lack of the efficient recycle ecosystem creates the uncertainty regarding residual value and environmental liabilities. And it requires policy framework and investment for repurposing the EV battery for the energy storage. The last one, for the microeconomic barriers, we have the behavioral and informational barriers. There are two main reasons for the barriers. The first one, the consumer awareness and perception gap, and the second one is the status quo bias and risk aversion. The first one, for the consumer awareness and perception gap, the significant information asymmetries hinder the EV adoption, with the many consumer unaware of the incentive, charging option, or even maintenance. The next one, for the misconception about the battery lifespan itself, and it can be 3 until 5 years compared with the 8 until 10 years. And it can more exaggerated safety concern deter the adoption. The next one for the limited early adoption, restricted peer exposure and experiential learning, reducing the social normalization. And for the status quo bias and risk aversion, and we have the behavioral economics explain inertia through loss aversions and the status quo bias, and the absence of the established EV residual values in Indonesia's used car market amplifies perceived financial risk itself. Then for the commercial operators show the greater openness but require proven operational data for fleet scale adoption. Then this is for the global context, and this is the current international dynamics. And let's say we can put three topics: the foreign direct investment, the FDI and the geopolitical risk, the global technological shift, and the regional competition. Let's dive into the every single parameters. For the FDI and the geopolitical risk, Indonesia EV ambitions rely heavily on the FDI and technological transfer, particularly from the Chinese companies. The dominance creates the vulnerabilities, and the geopolitical tension may restrict the market access. The Western automakers are cautious due to the ESG compliance risk and regulatory uncertainty. The global technological shift, the explanation are the rapid evolution of the battery technology itself, introduce the exogenous risk to Indonesian nickel-centric strategy. Second one, the emerging technologies threaten to further reduce Indonesia mineral advantage. The third one, the global fast charging standard create the compatibility challenge for the Indonesian import. And Indonesia nascent R&D ecosystem lack of the capacity to track or influence these innovations, leading to the technological dependency. The last one for the last parameters is for the regional competition. Currently intensifying competition for EV investment within the Southeast Asia. Indonesia still have the higher logistic costs and skilled labor shortage and regulatory complexity, and it will create another problems and risk becoming a commodity exporter rather than the integrated EV hub without the addressing this microeconomics create the another factor. Then this is the synthesis for the EV adoption. We can get the three steps: the prioritizing two-wheeler electrification, integrating energy and transport policy, and adaptive industrial strategy. Then this is the summary for the policy recommendation for the every single barriers. The first one for the financial barriers, we can put the policy intervention. The number one, the TCO based subsidies shifting from the upfront to the operational support, the EV specific financing through state banks at less than 5% interest, the targeted incentive for the commercial fleet and two-wheelers, and for the infrastructure gap, maybe we can put the mandatory charging in new building and the fuel station. We are going to get the off-peak electricity tariff for the EV charging, and public-private infrastructure funds with the risk-sharing mechanism. For the supply chain constraint, and the ESG certification for the nickel mining is a must. Battery recycling incentive, the R&D partnership with the Global Battery Forum on the LFP alternative. For the behavioral barriers, maybe we can start to get the national EV awareness campaign, demonstration fleet for ride hailing, and standardize for the battery warranties. The last one, for the global integration, we can start to do the bilateral trade agreement for the EV components, the Asian charging standard harmonizations, and get the special economic zone for the streamlined regulation. Goes to the last part, it's gonna be the conclusion. It can be the pathways to the electrifications, and Indonesia EV transition is a complex economic transformation impacting the consumer behavior, industrial organization, and global value chain. The identified microeconomic barriers, financial, infrastructural, industrial, and behavioral, are significant yet conquerable. The overcoming these barriers required an integrated ecosystem strategy, aligning consumer and manufacturers' economic within the Indonesia's unique context. Success depends on the policy coherence, strategic sequencing, and adaptive learning from the global shift. EV are a test case for Indonesia's ability to leverage natural resources for industrial upgrading and sustainable development, supporting our goal to be Golden Vision 2045.